Hi, I'm Luca Piras from Eurecat, the Technology Center of Catalonia. I'm excited to present you the work that I wrote together with my colleagues called Introducing HoNCAML, Holistic No-Code Auto Machine Learning. As you all know, in the recent decades, machine learning has been changing the landscape of many industries, and organizations in basically all sectors are integrating machine learning solutions to stay competitive. Automation learning has emerged to fill the technological gap, but many challenges are still open. In particular, we believe that the democratization of machine learning is still not complete, since the majority of current automation learning solutions still require expertise in both machine learning and programming. With these premises in mind, we designed and developed a library called HoNCAML, which is an automation learning tool designed to provide an extensive and easily accessible resource to users with varying degrees of coding proficiency and different levels of machine learning expertise. In this way, including both machine learning experts and users which are non-programmers but might still benefit from the advantages of machine learning. The name of the library consists of an acronym in which the term holistic stems from the belief that the auto machine learning problem should be addressed as a whole, so considering the interconnections between its subproblems. On the other hand, the term no-code stands for the capability of executing the tool without writing a single line of code. HoNCAML has been implemented as a Python library and released on the Python package index, so easily downloadable via the pip tool. And the source code has been released publicly on a GitHub repository. Besides, the execution of HoNCAML is based on editable configuration files that address different levels of expertise. And the library has been designed in a modular and extensible fashion that allows people to integrate the tool in their own solutions and to customize and to extend it with new functionalities. One of the main strengths of HoNCAML is its versatility when it comes to user interface. We particularly stress the importance of the graphical user interface and the command line interface, since these two are the modalities that empower the no-code paradigm. The graphical user interface responds to the needs of basic users and is also useful for fast prototyping. On the other hand, more advanced users also have the option of a command line interface, while the definition of a Python API is still a work in progress. Let's take a look at the graphical user interface. We developed it using Streamlit, which is a useful tool to build web applications in a relatively easy way. In the main section of the web app, you can upload a dataset on which you want to apply some machine learning pipeline. In this case, we have a quite standard dataset of flats and houses with several features, including the price. Let's suppose we want to predict the price. We need to set this feature as the target of our machine learning task. And let's proceed to using advanced configuration to illustrate all the functionalities of the graphical user interface. And let's select a benchmark pipeline, which consists in basically comparing several models in terms of performance. In the next section of the web app, you can select some basic configuration, such as the problem type. In this case, it's a regression because, as we said, we want to predict the price, which is a continuous variable. And we can also select the features that we want to include in our training. In this case, let's keep all of them except the ID of the flat, which doesn't have any predictive power, so it doesn't make much sense. Then we can apply pre-processing operations such as feature normalization. Here, for this example, just for illustrative purpose, let's suppose we want to normalize number of bedrooms and number of bathrooms. We can also normalize the target, but for this example, let's keep it as it is. Next, you can select the models that you want to include in the benchmark, and you can configure the parameters that you want to optimize for each of them. For this example, let's suppose we want to keep a linear regression, just for a quick example, and we add also a neural network. As you can see, all the main parameters of this algorithm are customizables. In this case, number of epochs, the layer number blocks, and so on. Finally, we need to choose which metric to use for our benchmark. In this case, let's keep only R squared for illustrative purposes. And let's select also the same metric for cross-validation with 5 splits, which is also a configurable parameter. And let's run the experiment. After a while, that of course depends on the number of models that you included in the benchmark, the size of the dataset, and other factors, the results will appear in the bottom part of the web app. You will be reported with the best model among the ones included in the benchmark, and a table with all the configurations and the metric obtained for each one. You can also download the file as a CSV. First of all, we validated HoNCAML through a quantitative evaluation, which consists of a benchmark on 6 classification and 6 regression datasets against 8 competitors. The competitors are other auto machine learning libraries that were selected basically with 2 main criteria in mind. They need to be publicly available as open source, and they need to be associated with a scientific publication. This was done in order to guarantee both reproducibility and transparency of the methods. In this plot, you can see a comparison of HoNCAML on 3 classification datasets, and each shape in each image stands for a library, and HoNCAML lies at the crossing of the dotted lines. On the x-axis, you can see the number of seconds, which stresses out that HoNCAML is always among the quickest tools. And on the y-axis, the f-score is reported. And it is noteworthy that our library is always among the most accurate ones. Analogous considerations can be made for regression. Also in this case, HoNCAML is one of the most efficient libraries, at the same time guaranteeing solid performance. After validating HoNCAML from a quantitative point of view, we performed a qualitative evaluation, which had the goal of assessing and comparing its functionalities in terms of user interface, user experience, and what it has to offer to the users in general. We can see from this table that as far as interface is concerned, HoNCAML represents the most complete option, since it covers both command line interface and graphical user interface, which are the 2 modalities that allow the no-code paradigm. Also, we mentioned that an API is currently a work in progress. And besides, as most of its competitors, it covers both machine learning and deep learning models, and it covers all the typical steps of the machine learning pipeline, except for feature engineering, which will be future work. This was just a glimpse on what HoNCAML can offer. Of course, you can find more information both in the GitHub repository and in the paper. We invite you to write us in case you're interested or you have any doubts. We invite you to contribute to our project on GitHub and download the tool and give it a try. Thank you very much.